sampling distribution of sample mean x bar drawn from the Poisson distribution. Here we have to find out the sampling distribution of Poisson distribution with sample mean. They are giving sample mean. Here we have to take, let x1 comma x2 comma and so on xn be a random sample. Drawn from Poisson distribution. Here they are giving only sample mean from the Poisson distribution. So we are just taking the random sample from the Poisson distribution. Let the samples be x1, x2 and so on xn. And here, what is the Poisson distribution mean and variance? In Poisson distribution, we have only one parameter. So expectation of xi, mean and variance. Expectation of xi is lambda and the variance of xi is also lambda. Here mean and variances are same in the Poisson distribution. Next, what they are giving? Sample mean they are giving. How can we indicate that sample mean? Sample mean as x bar. X bar is nothing but sum of all the random samples over n. Mean means we have to add all the observations with total number of observations. That is what I am writing. Next one, we have to find out the sample distribution. Before going that, we have to find out the expectation of x bar. Expectation of x bar is equal to expectation of x bar is the summation x by n. In expectations, constant will comes as same. In variances, constant will square and comes out. So here the constant is same and I am applying expectation of summation x. Summation x is nothing but we can split it as expectation of x1 plus x2 plus and so on plus xn. Next, split the expectation to individuals. 1 by n expectation of x1 plus expectation of x2 plus and so on plus expectation of xn. Here in the given Poisson distribution mean and variances, if we keep I equal to 1 to n, we may get lambda only because here the Poisson distribution having the parameter mean as lambda. If we take an I equal to 1, expectation of x1 is lambda, and if we take an I equal to 2, expectation of x2 is also lambda. Like that, if we take an I equal to 1 to n, whatever it may be, the value is lambda, and this value is repeating n times, and we can write it as 1 by n lambda. So 1 by n lambda can be. Next, expectation of x bar equal to n lambda over n. Both n and n, numerator n and denominator n will cancel. Finally, expectation of x bar is equal to lambda. Like this, we have to find out the variance of x bar also. Now, its variance of x bar. Variance of x bar can be represented as summation x by n. So, here I already told you in the beginning. Here, expectation of constant comes out as a same, but variance of constant comes out as a square. So, x1 by n comes out like a 1 by n square. Variance of summation x. Again, we can split this. Variance of summation x can be splitted as x1 plus x2 plus and so on plus xn. 1 by n square into, apply the individual, the variance. Variance of x1 plus variance of x2 plus variance of xn. So 1 by n square. If we keep variance of xi is lambda in place of I equal to 1, 2, 3 and so on n values. All the values will exist as lambda plus and so on plus lambda. Lambda can be repeated n times. So we can write it as 1 by n square into n lambda. This is 1 by n square n lambda. Both numerator and denominator is having 1 n. We can cancel that. Finally, variance of x bar, we got it as lambda over n. Next, we need to find out sampling distribution. What is the meaning of sampling distribution? Means we have to find out the standard error for the distribution. So standard error of x bar is equals to square root of variance of x bar. Variance of x bar is lambda over n. So therefore standard error of x bar equals to root lambda over n. This is the answer. Find the sampling distribution of sample proportion from a binomial distribution. Here we have to find out the sample proportion from the binomial distribution. For that we have to take a sample, random sample. I am taking, let x1, x2 and so on xn be the random sample from binomial distribution. So here we have to take from the binomial distribution as a random sample. If we are taking from the random sample from the binomial distribution, here population will exist. Here let capital P be the population proportion. We can indicate capital P as the population proportion. And small p can be indicated as x by n as a random sample with number of observations. Be the sample proportion. In the overall population, we are taking a sample. This is capital P is the population proportion and small p is the sample proportion. Here we are taking from the population, total population, we are just taking the sample from the total population. Now, we have to find out sampling distribution. Sampling distribution is nothing but expectation of, standard error. We have to find out the standard error. Before going to that, we have to know that expectation of x is equal to NP. In the binomial distribution, mean and variances are NP, NPQ. So expectation of x is NP, variance of x is NPQ. Q is nothing but 1 minus P. Next thing, here now we have to find out the sampling distribution. For that, expectation of x bar equal to, expectation of x bar is, here we don't find out x bar because we are taking sample from the population. So here we have to find out expectation of P. Expectation of P is equal to expectation of, this will be the sample, expectation of x by n. So expectation of x by n can be written as, we already told that a constant will comes out as same, 1 by n, expectation of x. What is the value of expectation of x in the given problem? In the binomial distribution, mean is NP. So we can write expectation of x as NP. We have to just replace this. So 1 by n into NP. Both numerator and denominator is having n. So expectation of small p equal to capital P. This one is the expectation. Next one. Variance of P. Variance of, again, P is equal to x by n. So we can write it as variance of x by n. Here constant will comes out as a square, 1 by n square into variance of x. 1 by n square into variance of x is NPQ. So both numerator and denominator get cancelled. PQ over n. This one is variance of P. So variance of P is PQ by N. This is the problem, and here we have to find out the sampling distribution. So sampling distribution is nothing but the standard error. So standard error means square root of variance of P. So square root of variance of P is root PQ by N. This is the final answer. This one is the sampling distribution of sample proportion from a binomial distribution.